We are building something we can no longer control. To the early AI, a cat was merely a machine. You constantly hear the buzzwords, artificial intelligence, machine learning, and deep learning. But they don't. Knowing the subtle differences between them is the secret to understanding how.
Here is the problem.
If you use deep learning to predict a simple spreadsheet, and if you try to build a self-driving car using traditional machine learning, you'll waste thousands of dollars in computing power. Using the right tool for the right problem is the key to building intelligent systems. With global AI spending reaching hundreds of billions of dollars,
AI investment is growing at an extraordinary pace.
and AI engineers are among the world's highest paid professionals.
This technology is reshaping every industry on Earth. You can't afford to stay in the dark.
Let's crack open the middle doll. Machine learning. Traditional machine learning requires feature engineering. A human expert has to manually tell the computer what to look for. You feed it structured spreadsheet data to predict house prices. But deep learning changes everything. You simply feed it thousands of house photos, and its neural networks discover the patterns. Machine learning needs guidance. Deep learning learns automatically. That's the biggest difference between machine learning and deep learning. Deep learning is doing all the heavy lifting. It is a true data glutton. Machine learning eventually reaches a limit, while deep learning keeps improving. The more data it receives, the smarter it becomes. Machine learning can efficiently run on a standard CPU. Deep learning demands powerful GPU clusters. And even specialized TPU hardware, handling millions of complex calculations in parallel. That's why deep learning requires far more data and much more powerful hardware than traditional machine learning. But here is the dark side of deep learning. This is known as the black box problem. Machine learning is transparent. You can trace exactly how every decision is made. Deep learning uses dozens of hidden layers. The mathematical pathway becomes incredibly complex. Even the engineers who built it cannot fully explain every decision. It gives you the answer, but not the explanation. Machine learning explains the journey. Deep learning often reveals only the destination. Let's look at the financial sector. Banks have perfectly structured transaction databases. Every purchase creates a predictable financial pattern. Then suddenly, an unusual transaction appears. Machine learning immediately detects the anomaly. And most importantly, it can explain exactly why. That's why traditional machine learning is trusted for fraud detection in banking.
But what about self-driving cars?
You can't put the chaos of a city street into a neat spreadsheet. Autonomous vehicles rely on deep learning to navigate complex environments, processing massive amounts of unstructured visual data. It automatically learns to recognize objects. Its intelligent systems easily recognize pedestrians, ensuring a safe journey. Its deep neural networks learn to perceive the world.
This is how deep learning enables self-driving cars to understand the world around them.
So, here is your ultimate rule of thumb. If you have a smaller amount of structured data, we need to explain your decisions. But if you have massive amounts of images, videos, or text, and only care about maximum performance, choose machine learning for structured, explainable tasks. Choose deep learning for If this video cleared up the AI fog for you, don't forget to subscribe to discover more. Next week, we'll explore the rise of agentic AI,
where autonomous AI age agents become our digital co-workers.
Leave your biggest AI question in the comments. Thanks for watching, and I'll see you in the next one.